Previously in Form 2, we were dealing with Topic 2, the chemistry of the mole. In Lesson 2, we were dealing with the relationship between molecules and the mole, and also relationship between mass of an element and the mole. So in Lesson 3 today, we are dealing with the relationship between the relative formula mass and the mole. Relative formula mass can be written RFM. RFM, relative formula mass. So we are still using the triangular formula. That triangular formula where we were having the mass up and we were having moles or number of moles and we are having the molar mass. So in our case, we are dealing RFM or relative formula mass as our molar mass. Okay, to start examples, we are told calculate the number of moles in 4.4 grams of carbon dioxide. So I'm told the number of moles. So if I want to calculate the number of moles, I have to take first of all mass, then I have to divide by the molar mass. In our case here, I'm dealing with a compound like carbon dioxide. I will look for the relative formula mass, the RFM of that carbon dioxide. So I start first of all getting RFM of carbon dioxide. We are told in bracket carbon is 12, the RM of carbon is 12 plus, then oxygen is 16, so I have 2 of oxygen, so this one it will be 44. So if they are looking for moles or number of moles, it is equal to mass over RFM. So in our case, mass is given 4.4 divided by the RFM, which we have gotten as 44. So here, we are going to get 0.1 moles of carbon dioxide. So that's how we are going to do that example number 1. In example number 2, we are told 2.5 grams of sodium hydrogen carbonate. So it's part B. So the question is the same. It is calculate the number of moles in. We are dealing 2.5 grams of sodium hydrogen carbonate. So the procedure is the same. We have to look first of all the RFM of sodium hydrogen carbonate. So learners, if you don't know how to write sodium hydrogen carbonate in chemical symbol, I mean in chemical formula, you will not get the relative formula mass correctly. Then that means your number of moles calculation will be wrong. Okay, and A here is 23 plus 1 hydrogen, which is 1, plus 12 for carbon, plus 16 times 3 for that of oxygen. So if you add all this, we are going to get 84 as our RFM. So to look for moles, the formula for calculating moles is mass over RFM. Okay, here my mass is given 2.5 divided by the RFM, which I've gotten 84. So here, if you put this one in your calculator, we are going to get 0.0298 moles of sodium hydrogen carbonate. So next, we are told calculate the mass. So using the triangular formula, mass can be given by moles multiplied by molar mass or the RFM. So let's just try to calculate the mass of 0.1 moles of sulfuric acid. So I have to get still RFM first of all, RFM of sulfuric acid. So here I'm having 1 times 2 for hydrogen plus 32 for sulfur, then plus 16 times 4 for oxygen. This will be 98. So mass will be equal to moles times molar mass or RFM. So my moles is 0.1, it has been given, times 98 for my RFM. So this one will give you 9.8 gram. 9.8 gram of sulfuric acid. The next part B, it's the same, calculate the mass of. So we are going to say the RFM of propane. RFM of propane. Propane is written C3H8. This will be equal to 12 for carbon times 3 carbon plus 1 for hydrogen times 8 hydrogens. So this will be 44. Okay. Thereafter, we are going to say mass can be gotten by moles multiplied by RFM. So the moles is given here, 1.6 moles multiplied by the formula mass, RFM, the relative formula mass of 44. This one, what are we going to get using the calculator? We are going to get 70.4. 70.4 grams. That is our mass. So it is 1.6 times 44, 70.4. Next, after that, let's go question number 3. In question number 3, we are told substance X contains a mass of 12.5 grams in 0.05 moles. So calculate the molar mass of the substance. So using the same triangular formula, if you are told calculate or determine the molar mass, the formula will be mass divided by moles. So here I have been given the mass and I've been given the moles. So let me write the formula molar mass. Molar mass can be given by mass over moles. So my mass is 12.5 divided by 0.05. So here, what are we going to get? We are going to get 250 grams as our molar mass.